Welcome to Key Skill 4. Now we're going to be getting into the nitty-gritty examples about how you can use the factor theorem and why it's useful. Question 1 says, use the factor theorem to determine if x minus 1 is a factor of, and then we've got a cubic polynomial. What we're going to do here is, first of all, remember we know that the factor theorem says that x minus a is a factor if and only if f of a is equal to 0. Now in our case, f of x is this cubic equation here. Okay, now we need to determine what is a. So we can start here where we put x minus 1 equal to 0, therefore x is equal to 1. So that's going to be our a, that would have been our x minus a here. So we've got to see if f of 1 is equal to 0. If f of 1 is equal to 0, then we know that if f of 1 is equal to 0 going this way, that x minus 1 is a factor. Okay, so here we go. F of 1 is equal to 5 times 1 cubed minus 3 times 1 squared plus 2 times 1 minus 4. Okay, so 5 times 1 cubed is 1, so 5. 1 squared is also 1. Remember, you always want to do the power of 2 before doing multiplying by minus 3. So 5 minus 3 plus 2 minus 4. 5 minus 3 is 2. 2 plus 2 minus 4. So that's 0. So f of 1 is 0. So we can therefore say, therefore, x minus 1 is a factor. If you wanted to verify that in the next example, we will. You could use long division and show that at the end there was a 0 remainder. However, the factor theorem is much quicker and more efficient than using long division. Okay, use the factor theorem to verify that 3x plus 1 is a factor of this cubic equation. So again, we're going to start in the same way. We're going to say 3x plus 1 is equal to 0. 3x is equal to minus 1, because we'd have 0 minus 1. 3x is equal to minus 1. X is equal to minus a third. That's our a. Okay? So we have to see now if, when we substitute that into f of x, 6x cubed minus x squared minus 4x minus 1, if that will equal to 0. Okay? It should do, because we've been asked to verify. I'm going to put in minus a third here. So 6 times by minus a third cubed minus a third squared minus 4 times minus a third minus 1. When you type this into a calculator, you want to be really mindful to include these brackets here. So we've got 0. So that's verified that 3x plus 1 is a factor. Now to fully factorize, we need to use long division. So we've got 6x cubed minus x squared minus 4x minus 1. We're going to use our long division here. And once you know one factor, it's really easy to find the other factors. We divide it in with the long division. So this is obviously the dividend, this is the divisor, to find the quotient. So 6x cubed divided by 3x is 2x squared. We multiply, will be 6x cubed plus 2x squared. If you've jumped in here in the middle and you don't know how to do your long division, you need to go back and check out Key Skills 1 and 2, where we really thoroughly learn how to do this. So here we'd have minus x squared minus 2x squared minus 3x squared minus 4x, bringing that one down. That would be plus 1x. Sorry, that would be minus 1x. Here would be minus 1. Okay, so you can see that it's definitely a factor. It's divided in and given us a 0 remainder here. Okay, but we already knew that. The useful part now is we know that 6x cubed minus x squared minus 4x minus 1 is equal to 3x plus 1 times by this quadratic equation. But that's not fully factorized because we can factorize the quadratic and go one step further. So 3x plus 1. Now, we can go one step further and factorize this quadratic. This quadratic is what we call a non-monic quadratic because it starts with a 2. So to factorize this type of quadratic, I would do 2 times minus 1, which is minus 2. So I want to multiply for minus 2 and add for minus 1, or the middle term. Sometimes people call this the glasses because you times these two together here. So 2 times minus 1, minus 2, and add for minus 1. So in this case, I want to do minus 2 times by 1, which will work for both of these. Minus 2 times 1 is minus 2. Minus 2 plus 1 is minus 1. And what you do is you split the middle term here. Well, let's just work this quadratic out on its own down here. So you've got 2x squared minus 1x minus 1. You split the middle term here. Then you factorize the first two and the last two using the highest common factor method. So we look at what we can take out from these two. We can take out a 2, and from x squared and x, we can take out an x. So it'd be x minus 1. From these two, we can't actually take anything out. So we take a plus 1. And now you can see these have a common bracket here. Okay, and the other bracket we can get from what's in front. So the first bracket will be 2x plus 1, and the second bracket will be x minus 1. Then we substitute these two in here. And now we have our fully factorized cubic equation. Okay, in question 3, we've been asked to fully factorize a cubic equation, but we haven't been given any factors. Remember, if we had one factor, we can do the long division to get us started. However, there is a little trick. What you can do is you can look at the factors of the final term, the term independent of x. So for example, minus 10 could be plus or minus 1 times plus or minus 10. So either plus 1 times minus 10 or minus 1 times plus 10. And the same for 2 and 5. What we're going to do is we're going to try to substitute these numbers into this cubic equation to find out the first factor. Once we've got one factor, we can do the long division. We're going to know that we found a factor by using the factor theorem. So for example, if we put in plus 1 here and we get an answer of 0, we can then work out the corresponding factor and get going. So it's a little bit of guesswork in the beginning. So for example, let's start with 1. Minus 21 times 1 minus 10. Okay, that one's not going to work. Let's try minus 1. Okay, that one's not going to work. Let's try 2. No. Minus 2. Bingo. So we know that f of minus 2 is equal to 0. Okay, so by the factor theorem, it would say that x plus 2 is a factor. Okay, now we've got one factor, we can do long division. Now we've got to be a little bit careful. If you remember back in key skill 2, we said that we always need to have a column for each power. So we've got x cubed. There's no x squared term here, so we do 0x squared minus 21x minus 10. And we've got our factor now, x plus 2. Okay, so 4x cubed divided by x is 4x squared. Multiply, multiply. Now this would be plus 8x squared. Need to subtract. Okay, 0x squared minus 8x squared. Drag down the minus 21x. Let's divide to see the next term in the quotient. Minus 8x squared divided by x is minus 8x. Multiply. Minus 16x. let's subtract, that would be 0. Minus 21x double minus 16x would be minus 21x plus 16x would be minus 5x. Drag down the minus 10. Minus 5x divided by x would be minus 5. And we multiply. Again, the 0 reminder verifies the fact that x plus 2 is in fact a factor. Now we can say that 4x cubed minus 21x minus 10 is equal to x plus 2 times by the quotient, okay? So this is basically the f of x, this is the factor, and this is the quotient, if you think about back to our proof for the factor theorem. Now we need to factorize this quadratic to finish off. So we want to do 4 times minus 5 is minus 20, and we want to add for minus 8. So we need to have, sign-wise, a minus times a plus. Okay, and we need to have the minus as the bigger one, because when we add them together, we want to get minus 8. So we could do here minus 10 times positive 2. That's going to work, minus 10 positive 2. And we split up the middle term. So we split up the minus 8x into minus 10x plus 2x minus 5. It doesn't matter which way around you put them in. You can split it into 2x minus 10x or minus 10x plus 2x. We group the first two and the last two and take out the highest common factor. So here would be 2x. That would give me 2x minus 5. Here I can't take anything out from both of them, so I just put plus 1. And the first two, these two make a bracket, and the repeated bracket is the second one. So the final factorization is x plus 2, 2x plus 1, 2x minus 5. And this is going to be super useful later on when you're drawing the graphs of the cubics. Question 4, x minus 2 is a factor. We've been told that. Find a. Well, again, we can use the factor theorem and say if x minus 2 is a factor, that means that f of 2 has to be equal to 0. So we have f of x equals to x cubed plus ax squared plus x plus 6. So f of 2 would be equal to 2 cubed plus a times 2 squared plus 2 plus 6, substituting 2 everywhere that we had x. So f of 2 is equal to 2 cubed is 8 plus, again, the power first, 4 times a, plus 2 plus 6 is going to be plus 8. So f of 2 is equal to 16 plus 4a. Now we know by the factor theorem that f of 2 has to be equal to 0. So we put a 0 here, 16 plus 4a. We move the 16 across and divide by 4. And then we've calculated that a must be minus 4. Okay, you can substitute back a here into the original equation and just double check this if you want. So we know here, or we can even use this line better, that if a is minus 4, so minus 4 would go there. So 2 cubed minus 4 times 2 squared plus 2 plus 6, that should be equal to 0 if we've done everything correctly. Okay, last one. 2x minus 1 and x plus 5 are factors of this cubic equation. Find a and b and hence fully factorize. This is very similar to the previous question. We're going to use the same technique, but we've been given 2 factors and 2 unknowns. So it's going to end up with a simultaneous equation. Whenever you've got 2 things to find, in this case a and b, you need 2 equations and you have to solve them simultaneously. So we're going to do this twice. Let's start with 2x minus 1 equals to 0. so we need to substitute in a half. So this means that f of a half will be equal to 0 if 2x minus 1 is your factor. That's what the factor theorem tells us. So let's replace a half everywhere. So we're going to have a times a half cubed plus a half squared plus b times a half plus 20. That's going to be our f of a half. Okay. So that would be 1 over 8 plus a half squared is 1 over 4 plus b times a half plus 20. Now we know that by the factor theorem this needs to be 0. I personally don't like working with loads of fractions, so I'm going to multiply everything by 8 because 8 is the lowest common multiple of 8, 4 and 2, so that I get some nice whole numbers to work with. So an 8th times 8, we can times each one by 8. Times by 8, times by 8, times by 8, and times by 8. This will also be times by 8, but 0 times by 8 is just 0. So this would be a quarter times by 8 would be 2. A half times by 8 would be 4, so we have 4b, and 20 times by 8 would be 160. So we would have, if we add all our like terms together, a plus 4b plus 162 equals to 0. And I move the 162 over here. Minus 162 is a plus 4b. That's going to be my first equation. I'm going to keep that safe and repeat the process for the second factor to get the second equation. The second factor is x plus 5, so x plus 5 equals to 0. X is equal to minus 5. Remember, that's the factor. This is the root. So we started with f of x equals to ax cubed plus ax cubed plus x squared plus bx plus 20. So we need to calculate f of minus 5. So minus 5 cubed plus minus 5 squared plus b times minus 5 plus 20. Always keep these brackets when you're substituting, especially if it's a negative number. So this would be minus 125a plus 25 minus 5b plus 20. This is 0 because x plus 5 is a factor. So that means that f of minus 5 has to be equal to 0. We can add together our like terms. Okay, that's going to give me plus 45. I'm also going to divide by 5 to make these numbers a little bit nicer. We can bring the 45 over and divide by 5. So I'm going to divide by minus 1 to keep it all positive. So that's my second equation that I've got to work with. To finish this off, I need to just do a simultaneous equation to solve for a and b. Okay, I'm going to multiply this line by minus 4. For my simultaneous equations, I like this number here to be the same. So, for example, now it's 1, and I like the signs to be opposite. So this would be minus 100a minus 4b, and this would be minus 36. Okay, so a take away 100a would be minus 99a equals to minus 162 minus 36 minus 198. So now you just need to divide minus 198 by minus 99, and that will give you a is equal to 2. Once you've got 2, you can loop back to your first line. So in my case, I would loop back to here. And you can substitute a is equal to 2. to calculate b. So here's a, we can put there 2 instead. Plus 4b equals minus 162. 4b equals minus 162 minus 2. 4b is minus 164. And we divide that by 4, which is minus 41. So now we've got a and b. Okay. Now it asks us also to fully factorize now. Now we know what a and b are. We can substitute them back into the original equation. So we know that a is 2. So we've got 2x cubed plus x squared minus 41x plus 20. Now there's a couple different ways to do this. We're going to divide. You could, if you're more comfortable, you could just divide by either 2x minus 1 here, or you could divide by x plus 5. That would give you a quotient that's a quadratic, and you could factorize that. I'm going to go a little bit faster. I'm going to multiply my two factors together. Okay, so I'm going to say 2x minus 1 times by x plus 5. So I'm going to multiply that out. So it's going to give me 2x squared plus 10x minus 1x minus 5. So 2x squared plus 9x minus 5. I'm going to divide by that instead. It just saves me having to factorize the quotient later on. And it's actually faster, obviously, to divide by 3 times than to divide by 2. So here we go. Remember, we're going to be working with 3 columns in our block now. 2x cubed divided by 2x squared is going to just be x. So we multiply each one of these by x. 2x cubed plus 9x squared minus 5x, we subtract. That would be here minus 8x squared. And then here would be minus 36x, and we would round down the 20. We would divide this by 2, x squared, that would be minus 4. Multiply each one. Okay, so we can see that our cubic factorized was equal to this times this, 2x squared plus 9x minus 5, the divisor times the quotient. And we already know from previously that this was, what was it? It was 2x minus 1 times x plus 5. So that's fully factorized. That brings us to the end of factor theorem. There's quite a lot of exam questions to do now. This is a frequently examined topic. So definitely look at those before you move forward onto the remainder theorem. We've got 2 key skills left in this course, all about the remainder theorem. It's very similar. It's not going to get much harder from here on out. You've done all the hard work. So get your exam questions done into your workbook, and I'll see you in the next key skill. Bye for now.